In this demo, we will look at a containerized application running on a Kubernetes cluster. We'll see how we can use Cisco Secure Workload to secure such an application. Let me first show you the application that I have deployed on a Kubernetes cluster. So this is a simple microservices based application. It's deployed in the namespace stock shop. There are about 13 to 14 pods that are running, and each pod is front-ended by a Kubernetes service. So each pod has a equivalent Kubernetes service front-ending the particular pod. All of those services are of type cluster IP except the front-end service, which is of type load balancer, and that is how it is exposed outside the cluster. We can quickly access the application. So if I go to my browser, and you can see this is my application, which is running on this Kubernetes cluster. Perfect. Now let's jump into Cisco Secure Workload console and see how we secure this environment. So you're looking at SOC Shop application on the console. This application, if you pay attention to the matching inventories tab, you will see this is where we have discovered all the pod and service inventory corresponding to this particular application. So you can see there are 14 services that have been discovered along with the load balancer service. And there are about 16 pods that are running behind each of those services. If I click on an individual service, and let me open a pod as well, I navigate to a service profile page, and this is a carts service. You can see here how we have learned all the different attributes about this particular service. There are a whole bunch of them, so about 20 odd attributes associated with this service, which include the name of the service, the namespace it is running on, the Kubernetes cluster it is running on, and other such details or attributes or labels or annotations that you can use to build policies. Likewise, if I jump into the pod profile, this is for carts profile. You can see all the associated attributes here. What is the Kubernetes node where this particular pod is running, what sort of annotations that are associated with this particular pod. So you can see name equals carts, and let me quickly show you that on the UI, on the CLI as well. So if I run this command, I'm looking at the carts pod and I'm seeing all the labels. You can see I put a label on it, name equals carts, and that is also getting discovered by Cisco Secure Workload. So not just the labels that are automatically added by the orchestrator, but also the manual annotations that are tagged on the individual pods, those are ingested as well. Let's go back. So we have discovered all the assets or pods and services associated with SOC Shop. Next up is policy blueprint. So if I toggle, this is a list view where you can see all the different policies and ports that are opened. We follow a allow list model where you specify the specific ports that you want to allow, and anything else is catch-all deny. So anything that is not defined as allowed here will get denied. If I toggle from this list view to a visual graph, and just makes it a lot more easy to follow things here. Let's pick this. So I have a bunch of users, filter defined for my set of users. These users can be defined. If you look at the right hand side, you can use straight up IP address queries to define these users. You can use ICE attributes like username or SGTs to define these filters, or you can even define LDAP attributes like member of to define these filters. So based on these queries, I have 3 matching user IPs which are allowed to access my front-end service on port 80, right? And that's how I'm accessing the particular application. If we go beyond this, the front-end services has a bunch of front-end pods behind it, and those pods are allowed to talk to another set of services, cluster IP services, each one on a specific port. And then likewise, we have defined the entire lateral movement in a very controlled manner. Now, if let's say I want to open a new port, it's as simple as dragging from the source or the consumer all the way to the destination. So let's say I want to open a new port going from front-end pods to payment service. Once I do that drag and drop, it prompts me for a port. Let me add that port. I'm adding some random port, and when I hit create, a new port is opened as well. At this point, I want to see what sort of communications are matching these policies, right? Can I get visibility into the network flows that are hitting these, that are going to hit these policies? So if we click, let's pick one of the flows as an example. So my front-end pods talking to orders service. So if I click here on the right-hand panel, if I click on this little flows button, it will take me to flow analysis or policy analysis page. And this is where I can see all the matching flows which are sourced from front-end pods and are communicating with order service. And if you see, these are all the flows that are matching this particular source and destination. And you can do this sort of analysis. This is live. So as and when communications are happening, it gets evaluated against the policies and shows up here. You can do this even without enforcing the policies. So just by defining the policies, you would start seeing this sort of compliance analysis. So now you can see if I click on individual flow, it gives me a lot more detailed information about the time for which this particular flow lasted, the TCP flags associated with this flow, the byte count, the packet count that was exchanged over this particular flow, and then obviously the exact policy that is going to get matched, which is front-end pods talking to order service on port 80 on the consumer side, that is source egress, and on the ingress side on the destination as well. So this is policy analysis. Let's go ahead and enforce the new version of policies. So we just added one new port. So you can see the older version was already enforced. So the enforcement workflow shows me the new policy that I've added. And then if I go through this workflow and accept enforce, at this point, the new port is going to get programmed onto the Kubernetes cluster as well. Let's verify some of these aspects. So I'm going to go to my policy canvas and let's pick this front-end pod, and you can see my front-end filter is currently matching and showing me 3 pods that are running on the Kubernetes cluster. Let's verify that. So I'm going to get pods -n sock shop -o wide. All right, perfect. So you can see these are the 3 pods. These are the 3 pods that are matching that particular filter. Now, what I want to do is I want to scale this deployment, the front-end deployment, to 4 replicas, right? When I do this, what I expect to happen is a 4th pod will get spun up, and we can see that's happening at the moment. The fourth pod is still in the process of getting spun up. Let's give it a second. Okay, the fourth pod is up now. At this point, if I go back and let's say I refresh this page, in just about few seconds, I should expect this particular filter getting updated with fourth pod. Let's give it a second. All right, now we see the pods are updated on secure workload side as well. So as and when we are scaling the deployment, the policies, our policy objects are getting updated dynamically without any manual input from the user on the secure workload side, and hence the policies are updated as well. Next, let's test and verify another use case. So in this one, we can see that frontend is allowed to communicate with payment service on port 80, but the frontend pod cannot communicate with, is not allowed to communicate with, say, an database service, orders database service directly. So there's no policy allowing pods, front-end pods, to communicate with orders DB on let's say 27017 port number, TCP 27017 port number. So let's test this out and then we can verify what we see on the secure workload console. So I'm going to go back here. Let's exec inside of the front-end pod. So I am shelled inside the front-end pod. So I'm going to do the command wget payment port 80, and you can see when I run the command, I am getting a response from payment service on port 80. The response is 404 HTTP response telling me there's nothing on this particular location, which is fine, but it verifies that it confirms that there was a connection that went successful from the front-end pod going to payment service. So this succeeded. Let's do the same thing for orders DB on 27017, and this time around you can see front-end pod is trying to connect to orders DB service, but since the port is not open, the connection is not going through and it's stuck at connecting. I'm going to try one more time and you can see the connection doesn't happen. So we can talk to payment, or front-end pod can talk to payment but cannot talk to orders DB. Let's verify this on secure workload console. So let's pick front-end pod talking to payment service, and we want to look at the matching flows. We can go directly to the enforcement tab. So consumer pod name contains front, and provider service name contains payment, right? And if I hit enter, I can see the flows that were permitted. Now likewise, if I do orders -db and search the flow, you can see those are the flows that are rejected. So this confirms our policies are doing what they are supposed to do. And that concludes the demo. Thank you.